All right, guys, last time we talked about some new numbers. We talked about complex numbers, imaginary numbers, and we talked about irrational numbers, right? And so we'll be dealing with those again today. All right, so we're just going to start off with a little bit of vocabulary about radicals. The number under the radical is called the radicand. This is just the radical symbol. And then this is the index. You've seen an index when you do cube root. When you have square root, they just don't put any number in there. So if you see that there's no index, then it's assumed that it's a square root. The index is just 2. So a square root is trying to find that number times itself gives you that radicand. If it were a cube root, it would be that number times itself 3 times would give you that radicand. But today we're just doing square roots. So last class we talked a little bit about how to simplify a radical, and we simplified a radical like 32 by splitting the 32 into factors like 2 times 16. 16 could be 2 times 8, 8 could be 2 times 4, and then finally 4 is 2 times 2. And then we were looking for those groups of 2 numbers that matched up, because those numbers would form those perfect squares. So this is going to give me the square root of 4. 2 times 2 is 4. This gives me the square root of 4. And then that's just like a square root of 2 that's left over. It's really tiny. Let's see if I can make that better for you. All right, and then the square root of 4 is 2. The square root of 4 is 2. And then the square root of 2 is just going to stay root 2. And for some reason, this answer is all the way over here. I'm just going to scratch it out because it's kind of lost over there. 2 times 2 gives me 4. And then I have root 2. All right, so I made a factor tree. I looked for the pairs. The pairs made these perfect squares. And then what was left over, that goes into its own radical as well. The perfect squares, I take their square root. And then the one that's left over, it stays under the radical. All right, so I want you guys to try the similar process for square root of 48. Always, of course, notice, look and make sure that the number itself is not a perfect square. If you're working with those calculators, let's try to find some buttons together on that TI. I'm going to pull up mine as well. Okay. All right, so when you turn on the calculator, if you have a weird screen like this, just go second, quit, and it should get you to a normal screen. You can press clear to clear out anything that's in there. And say I wanted to do square root of 48. Square root is above the x squared. So I would do second square root 48. And if I don't get an integer, then that's no good. But now maybe I just want to use the calculator to figure out what I can divide 48 by. I can divide 48 by 4. That gives me 12, so that's going to help me here. I can make a factor tree for 48, where it's 4 times 12. And then maybe I can break that up on my own. 2 times 2, 2 times 6, and 2 times 3. All right, so take a moment and see if you can simplify that radical. All right, folks, so you were looking for those pairs. So there's a 2 there and a 2 there, and then there's a 2 there and a 2 there, and then there's this 3 left over. Don't forget about that one. So I can write 2 times 2 is 4, so I have root 4 and another root 4 and a root 3. Some of you guys skip over that step with the root 4 and the root 4. So 2 times 2. And then root 3, and then 4 root 3, like that. What do we have to be careful about with number 2? It's a perfect square, right? So we don't have to do a factor tree? No, because what's the square root of 64? 8, right. Okay. Go ahead and try the next one. 9 works. Let's do 3 times 9, and then 9 can also be 3 times 3. And do we have any pairs? Yeah. So we're going to pair these up. But don't forget about that one. So 3 times 3 is 9, so I'm going to write root 9 times root 3, and the square root of 9 is 3. All right. Yes, I like questions.
If it's like a 1 in like an odd number, do I not like factor it?
Can you be more specific? I'm trying to understand.
Would I not put like 1 and 3 under the 3?
Oh, I see what you're saying. Yes, so if the only factor is 1 in the number itself, you don't factor it further. That's true.
If there's a 1, I just don't factor it.
Right. Yeah, because there's always a 1, right? I mean, you could, but it's just creating more work for yourself. It's not necessary. All right, so let's try number 4. Number 4 has a 2 in front, but I don't want you to get confused by that 2 in front, because the 2 in front, we're just going to multiply it by any other number in front at the end. So deal with the 54 right now, and then we'll deal with the 2 at the end. All right, so we're going to just forget that there's a 2 there, and we're going to deal with the root 54. So a lot of you guys did 54 was 9 times 6, and then you had 3 times 3, and you had 2 times 3. And I know that there's 3 3s, but you need 2 of them in order for it to be a perfect square. So this one's just like left over. So this is going to give me root 9. This is going to give me root 6. 2 times 3 is 6. That 2 still is out here. I'm just ignoring it for now. This gives me 3. So I have 2 times 3 root 6. And then finally multiply those to get 6 root 6. Okay, I'll come look at it. All right, so if you split it into square root of -1 times the square root of 81, I actually know the square root of 81. I can use my calculator and find out it equals what number? 9, good. And this one gives me I, so that's I times 9, which like technically is done, but we never write it that way. We always write 9i. Like we would never write x9, we would write 9x. All right, I think we did square root of -50 already, but we probably forgot about it. So -1 times root 50. Root 50, is that going to give me an integer in the calculator? No, doesn't work. So let's just do a factor tree then for the 50. I already know this part's I. Do a factor tree for the 50. For the 50, I saw a lot of you guys split it into 25 times 2, and some of you went to 5 times 5, but some of you are realizing you don't have to do that step, and that's okay. That part there gives you the 25, so I have square root of -1 times the square root of 25 times the square root of 2 still. Hi. And then those are giving me I times 5 times root 2. But eventually you want to put the 5 first. So it'd be 5i root 2. It's like grammar for math. That's just how we write things.
How do you know if the I is inside or outside the square root?
It's always outside. Okay, last one. I'm going to split it up to the -1 and the root 3. So I know the first part's in I. What about root 3? What can I do with that? Food for thought. I'm coming back. Emily Bro.
Yeah.
Can you say the name again? Oh, yes. Uh-huh. Okay. Thanks. Bye. Sub-school 225 for a couple minutes. Okay. Okay, so the answer is, of course, we can't do anything with root 3, right? Root 3 has no factors besides 1 and 3. That's not going to help us out. So we are going to just leave that as root 3. This is I, so you end up with I root 3. It's like this last class. These are just examples of problems that you would solve with square roots, so we're not actually solving these. I don't know why they're there, but we are going to solve this one. So we have to isolate the squared term. Do you see how the squared term is all of this, right? So to isolate it, we're going to get rid of the 3. Oh, and then we can use our calculator. So we'll do 54 divided by 3. And I get 18. All right, so I get the square of x minus 1 equals 18. Now, do you remember last class when we solved with square roots, it was not just the positive square root, it was also the what? The negative square root. So I'm going to do a square root on both sides like this, but I need a plus or minus in front. All right, plus or minus square root of 18, and then square root here. So what happens is the square root and the square cancel out, x minus 1, and I have plus or minus root 18, which eventually I'm going to have to simplify. But I'm still trying to get the x by itself. So how do you get rid of a minus 1? You're going to add it, yeah. Now these are not like terms, so they don't add nicely. I get 1 plus or minus root 18, and the last thing I need to do is simplify root 18. I know that answer looks messy. I know I could put it into a calculator and get a decimal, but that decimal will be an approximation and not an exact answer. So we don't put it into a calculator to get a decimal, but what we do is simplify root 18. What we do is simplify root 18. So over here on the side, I'm going to make my factor tree for 18. Find my doubles. Okay, so root 18 is going to be root 9 times root 2. Root 9 is 3, so I get 3 root 2. So this answer here becomes x equals 1 plus or minus 3 root 2. It's a bit of a messy answer. All right, so to undo multiply by 5, I divide by 5 on both sides. And I get x squared equals 8. And now's where I have to get rid of the squaring with a what? Square root, good. And I don't want to forget the what? In front of the square root. Plus and minus, yeah. The factor tree for 8. Okay, so x is going to equal plus or minus root 8, and then we're going to do a factor tree for 8, which is not that bad. 2 times 4, 2 times 2. I see that there's 3 2's, but they're not helpful unless they're in pairs. So those two I can pair together. That one's going to be left. So I have plus or minus square root. This times this is 4. That's just 2. And then that gives me plus or minus 2 root 2. Number 4, we're going to get rid of the minus 32 with a plus 32. So I have 2 times x minus 3 squared equals 32. Then how do we get rid of times 2? Divide, yep. All right, so the square of x minus 3 equals 16. How do we get rid of that square? Square root, yes. So x minus 3 equals plus or minus square root of 16. Yeah, what's special about square root of 16? It is a perfect square. Good. Do you know what it is? 4. Very good. All right. So I have x minus 3 equals plus or minus 4. This is going to be fun because we can actually make numbers out of this. All right, to get rid of the minus 3, I'm going to add 3. I'm just going to move my problem over here where I have more room. So x minus 3 equals plus or minus 4, and I'm adding 3. And I get x equals 3 plus or minus 4. These are numbers. There's no square roots anymore. So I can actually combine these. So I was here, and then I was there. 3 plus 4 gives me what answer? 7, and 3 minus 4? Negative 1. So x equals 7 and negative 1. All right, you guys are going to go and do problem 3 now. All right, I've seen a lot of good work. I'm just going to recap for people who aren't quite done yet. So I saw square root and square root. And then a lot of you remembered your plus or minus right here. So you had 2x plus 1 equals plus or minus 9. And at that point, some of you guys, you subtracted 1 and divided by 2, and then you simplified. But I think for some of us, it helped to split it into 2 problems. 2x plus 1 equals 9, and 2x plus 1 equals negative 9, since I knew that there were 2 different answers there. And then solving those separately, for some reason that just seemed easier. And that's okay, you can solve them separately or all at once, it's up to you. Dividing by 2, so this one gave us x equals 4. 2x equals negative 10. And this one gives us x equals negative 5. So I saw a lot of good work there. That's kind of tricky. All right, so we're going to add and subtract complex numbers. When you add and subtract, you only combine the like terms. So for number 16, what can I add to the 6? What's a like term I can add to it? 4, good. So 6 plus 4 gives me 10. What can I add to negative 2i? Is he right? Is it 5i? Yeah, good. So negative 2i plus 5i. Oh, if I forgot my negative numbers, I could pull out the calculator. Remember, these calculators are super useful. You just have to remember that the negative button is down here. So I'm not going to obviously put down here at the bottom. Okay? I'm not going to put the I in there. It doesn't do I, but I can do negative 2 plus 5 to combine the coefficients, and I get 3. So that's going to give me a positive 3i. All right? Try 17. Only combine the like terms. We didn't have one last time. All right. So combining like terms, 3 minus 8 is negative 5. 3 minus 8 is negative 5. Negative 7i minus 2i. You can use your calculator if you're not sure, but that is negative 9i. So remember, I'm just combining like terms. But when you multiply everything. You don't just combine like terms. So you can distribute. You can do 3i times 7, and that gives us what? Just multiply, right? What's 3 times 7? 21. So we get 21i. And then 3i times 2i. The 3 times 2 is 6. But what about I times I? I squared, right? So I get 6i squared. And then I do need to replace the I squared with what number? Negative 1. Good. So I have 21i plus 6 times negative 1. So 21i minus 6. All right, and then I'm going to distribute here as well. So I'm going to do 5 times 2 and then 5 times 4i. So I get 10 plus 20i. And then I'll distribute the 3i. So I have 3i times 2 and 3i times 4i. 6i plus 12i squared. All right, so these two can combine. And this one I can replace with negative 1. So I have 10 plus 26i plus 12 times negative 1. And then finally I have to combine what two like terms? 10 and negative 12, right? So let me get this calculator out of the way. And these two combine to make negative 2 plus 26i.